Hello guys, hope you're doing well. In this video I'm gonna go through the journey how I got to this 700 and GL version overclocked. I'll be doing in this video from 505 all the way to 700 every single step of the way with all information listed, and I will start with updating my KS0 Ultra, three of them to 12 volt mining connectors XT60. I'll be soldering to the board. Let's get to it and we'll get through rest of the video. It's gonna be super long, so if you're annoyed, just scroll down through it. Sorry about that longest video I ever had, but hopefully somebody find the useful information throughout this video, because at the end I'll have data, and at the end you'll see how I got to this overclocks. All right, and during this video I actually didn't record it, but I bricked two of these miners, so I have to switch to the two different ones until I unbrick those two. Later in the video I had to use different miners to complete the video basically, but the bricked unit I already unbricked it and it's mining, so it's all fine. And stay tuned for the update for this miners running 700 gigahash, and we'll see after a few days. It's only been 7 hours, so let's get to updating my connectors, power connectors, and get through the video. All right, I'll be soldering this XT60 female connector to the KS0 Ultra. So positive red, negative black. Make sure you keep that on the same side of your connector. And we will be going with, I'll be setting about 340 degrees on my iron, soldering iron, and let's get to it. I'm gonna just clean that up a little bit, the connection part. Not clean, but just to make sure we can solder to it. So I'm gonna use a little bit of the paste, and we're gonna make sure we have a good connection here. The positive is on the middle. This is the only positive piece here, so we need to break that down. And I'm gonna connect a little bit to this chip. I don't know if that's diode or resistor. I think it's a diode, probably for backflow prevention for the negative part, I mean positive side. So yeah, we'll be just make sure that we have the good connection to it, because only positive connect wire here is very skinny, thin. All right, so let's get that done. So we have a pretty good area to get our positive connector right there, and we can warm it up. Get some extra paste. Let's see if the 340 will warm it up good enough. This 14 gauge wire, the silicone wire, we're trying to, well, we'll probably add to 360 so we can get it done faster and more efficient. Yeah, I have to warm up this to be able to get a really good soldering connection right there. And now the negative part, basically between these two connectors, and then we will cover with electrical tape, so there is no potential short. Okay, so similar part. I'm just gonna warm up these two, get them ready, and pretty much scratch in between, so we have good connection to the board as well right there. So I can remove a little bit of that cover and just have it all like this to copper all the way through right there. Hope you could see that right there. And I'm gonna add a little bit of this rosin, and let's warm it up. Hardest part is warm up this thick wire with the board all together, but once we got a good warm up, we can do a really good soldering there as well. Perfect. All right, and at this point, once it's cooled down, we're just gonna make sure and pull test so that it's not loose, perfectly safe. And now it's ready to go. I need to reapply the thermal paste, obviously, because once you open the board, I need to clean all that from the case and from the chips, and then put the MX6 paste. That's what recommended, and this unit will be ready for overclocks because I already modded with the heatsinks. I'll get it on the fruition design to get good airflow, and we could test how high we can get it overclocked. All right, also I'm gonna add this little piece of electrical tape just to cover over this open connector, so I don't want anything touching it, especially positive side. The negative probably okay because it's all negatives around the board, but the positive will be mainly. Make sure there is nothing sharp sticking out like I have actually. A little bit of sharp left over from the soldering, so we need to clear that up. Yeah, so when I solder I left a little pin slightly sticking out, all right? So you have to smooth it out and apply that electrical tape right there. Okay, perfect. Now nothing sticking out. This is just an extra protection here, and it's ready to go. What do you guys think? It will handle 230 watts or 230 watts. A little bit extreme for this. Connector is actually fine. I'm just worried about the 14 gauge cable, the silicone wire. So far it was doing okay. It was not overheating or anything. So let's put it back together. Alright, so I'm done with this unit. So I have this connector soldered, even though I have 19 volt, I'm not gonna use it. I'm a fan of this 12 volt system because I have PSU and I don't like multiple 19 volt PSU. I don't want to order them because I already have power supply, so I don't want to waste money on that. And so basically everything is set to go. You could see how close this negative connector to this lip right there. By the way, the newer batch of the KS0 Ultras that I got, they went back to the same as the KS0 Pro cases. So when if you noticed, I removed the screws no problem. When they have the first batch of this KS0 Ultra, they use cases from KS0 Original. I don't know if you've seen my video. They have multiple of these wings, which was only on KS0 Original, and you couldn't easily remove those screws. They would pop out with the pins behind. So I don't know if this was one lucky unit or they're all new. I have two more redo. I did already two molded with the heatsinks, and now have to do three more actually. So this one already done, and these two done, and two other ones I put to mining, but I only welded soldered this connector to here, so I still have to do two more right there on these two miners, and then after that I will do the other two. So let's remove and see how this screws works. I don't know if this is just only one lucky unit or all of them on the new batch just came pretty much like the old KS0 Pro. So far looks good. Yeah, looks like the screws just individually going out like on KS0 Pro, so no problem on the new batch, I guess. Let me finish all of them, make sure I'm not mistaken. So far it's going okay. As soon as you feel like you're lifting up the board, you have to stop and then remove them a little bit by little so you don't bend the board. But so far they coming out okay. Maybe they use a thread lock or better thread lock on this one for this stance, screw stance. So far looks like they're coming out okay. Maybe this one was a little bit pushing out the board. Let's see if this is not lucky one. No, it was all right. Look, I got them all, 8 of them, no problem. Oh yeah, I could see that. Look at the thread lock. They use a bunch of that stuff right there on most of them, not every single one, but you could see it's all glued now. So hopefully they stay there, so it shouldn't be an issue now. And I will solder this connector now and the third one and finish with these 3 units, and we'll start testing them out. Alright, so I have finished my third one, so this one is done. I just soldered this one right here. Nothing sticking out, it's just a reflection. And I want to make sure I have a good bone to the positive here and the negative, because we're going to be pushing a lot of current through this connectors and through this wire. So just need to recase this two, put it back, and we'll be ready to go. So I have all 3 of these KS0 Ultra ready to go for overclocking. So both plates on the front and the back removed. And I'm gonna blow on the power side. The air is gonna blow on the power side. I'm gonna put friction design. And it's important to add one of these heat sinks right on top. That's basically gets your overclocked to the maximum. Okay, so let's get that connected, and I'll show you guys the power usage. All right, so you could see one of these already modded Ultra here online. I don't know if you guys could see those right there, the heat sinks, right? So it's all connected. Now I didn't solder the XT60 connector to this because I'm using 19 volt power supply for this test. So one unit gonna be on 19 volt, or it's 20 volt. It's 330 watts. It's Slim. I'll put link down below. Slim Q. That was a recommended high quality power supply, and it's running stock firmware. As you notice, there is no shroud or any extra fans, because it will reduce your hash rate on the stock if you cooling this down more. Okay, so right here we have 107 watts at the wall using this 19 or 20 volt power supply. Is it 19 or 20? Let's just check it out. It's very dark in here. I believe it's a description said 20 volts. Can't even. It's weird, different outputs. So DC output 20 volt, 16.5 amp, 330 watts. So it is 20 volt, but it's running fine because they're all kind of 19 volt, the up volt, because it's gonna drop voltage when you connect to the full load. So anyways, with that power supply connected here to my power meter, it's 107 watts right now, running stock firmware. It's been running over 24 hours, so I just have a good data. It's running 410. We can go and check on the web GUI. It's my Ultra 9. All right, and then I'll be overclocking this and then adding the shroud as we need after probably 562 version, because it will need additional air. Before 505 and 562, I guess, can be done without blowing in extra air, but we'll see how the temperatures on the MOSFETs and how the well, next to MOSFETs, wherever the sensors are, and what the power usage at 19 or 20 volt power supply compared to 12 volt power supply, which is I'm gonna show you right in a second. All right, now when our miner is ready to be connected to 12 volt, how am I gonna connect this to the PCIe server PSU port? So obviously you can solder to one of your GPU cables. Use 16 gauge only, do not use 18 gauge because it's gonna burn out right away. Even if you use 16 gauge, you gotta be careful because you put in a lot of load after 150 watts onto this connector. So unless this is very high quality cable, like mine, even though it's 16 gauge, it's pretty cheap, I think, because it's a Chinese, not branded wire. So what I'm gonna do, I'm gonna simply double this up. I'm gonna use 2 and connect to this adapter right here with the male connector over here. So it will be simply just connecting my, notice reds, it's positive, so you cannot reverse this. Make sure you use positive to positive when you solder, and this already sold pre-made. All you gotta do is just put in this quick connector. I'll put links for all of this down below in description, and I'm gonna cut this on half, and we'll use a double wiring for this specific connection, because we're gonna be doing maximum overclocks which will exceed one of this connector limit, which I believe it's 175 watts, but don't take my word for it. For these ones, I burned them even at 100, probably 50, depending how good is the quality. But doubling it, we go into 300 watts at least to prevent, hopefully, damaging. I've used double before, never failed, but singles did fail for me several times. So be careful when you do this. And by the way, when you modify your unit, you're pretty much out of warranty, so be cautious. Make sure when you do it, don't just take my word for it. Do your own research. When you're modifying and when you're overclocking, you're going to the risk of voided warranties on the unit. So now I'm gonna make sure, I need to make sure these wires are as close as possible in the lengths, because that's the current gonna flow through 2 of them, and we want to make sure they're very, very similar on the size of the wire, because on the low voltage especially, it's very important. Even a couple inches difference will do the difference on the amperage. Okay, so it looks like we are very, very close. Okay, that's good enough. Within maybe 1/8 of an inch or 1/16 of an inch, I think it's good. So I'm gonna clean this and double this up. So I'm gonna do 2 yellow wires at the time in each of these connectors. So let me strip these wires first. All right, so when I use a wire stripper, I get generally like about a little over 1/2 inch, maybe 3/4 of the wires stripped, and try to get them all pretty much equal, because they go pretty deep in this connector, and you want to make sure you get a good connector between each wire, so don't strip just a little tiny 1/4 inch, and I think 1/2 inch or even a little longer will make it a good connection. So now we'll be starting with the positive, which are yellow. So all I gotta do, just twist 2 cables here, 2 yellow wires here, and 2 yellow wires here. That's, I think, maximum I can fit. If I put 3 together, it's probably not gonna fit well in this connector, but 2 wires are generally fitted pretty well. Just need to kind of slide in deep enough to be able to lock this. Let's see, they're a little bit thicker on the 16 gauge to be able to slide all the way in right there. So when they slide in, you just lock them up and test them. Make sure you have a good grip, and then a block we're gonna separate on the other end. Then we get to do 2 yellows from the other side. So that's how we pretty much creating doubling 2 cables going into 1. And by the way, this connector capable of holding 30 amp, so hopefully this is not an issue holding 15 amp. I mean, it will be almost, if you think about 12 volt going to 250, we're gonna be close to 20 amp even, possibly, right? So I'm locking this up, all right? And then lastly, I do this last pair over here, and also pushing all the way in and locking it up. Oops, see, you gotta test it, make sure you got it all the way, because it will not lock if you're not all the way in. All right, perfect. Okay, so I have 3 of this locked in. It's pretty crowded. I mean, if you look at this, trying to get close, so, but they're pretty good. They're pretty well connected. There is no looseness at all. So we'll start now with this 2, doubling these 2 wires, and think about it, we're using 6 positive and 6 negative 16 gauge cables. So the wire is really size, it's not an issue. On the 16 gauge, it's really is a connector. The PCIe connector will start melting if you overload it after a certain amperage, I noticed, and typically going over 170 watts. That's why when you're using for GPU, if you remember GPU mining, you would do the open rigs frames, server PSU, and stuff like that. So you would just use these guys, double, and like 3090 cards or 3080 card, they even triple 3 wires PCIe goes into the single GPU. So that's the idea behind to offload from these connectors as much as possible so they don't overheat, because you'll be running them 24/7, right? And then also ambient temperature is really important. So they work sometimes when it's cooler, so they be able to cool, because it's cooler at night, and then during the day when it gets hot, especially in the summer, that's when you start to see these damages on this connector, because it will overheat definitely. And if it start heating connector, you cannot stop, it will just burn it down because the resistance goes up. All right, so right here, 2 connectors. So how am I going to be connecting them to the board? Basically 2 connectors. We'll just click there in parallel, and again checking again, you have positives all on this orange side, positive coming to the positive side, negative to negative, and we'll be ready to go to connect to the PSU. So let's go, and I have one already installed in my box mining, and we'll connect it there. All right, a little bit louder here. So I have all these KS0 Pro still left from the previous mining. 1, 2, 3, 4, 5, 6 of these guys, and then I'll start adding KS0 Ultra here So everything's set up with the fans, with my diffusers. The fans are 6,000 RPM, so capable to cool down this unit. So let's see how we're gonna connect this power to server PSU. So I'm gonna connect number one and number two. So this way I'm gonna offload a lot of amperage of this PCIe connectors, because look at that. I have burned down one connector there, one connector over here. If you could see when I overclocked to the KS0 Pro to the maximum. So what I had to do, I had to double those up if I go to the maximum capacity of their. So that's what we're gonna try to do to the maximize overclocks. And if we don't need to, if we're gonna go down, so now I'm gonna connect the watt meter. Actually, we're gonna be testing on my solar one. This one I'm just gonna connect and get ready for mining. And I'm gonna overclock the one that I pre-made on my solar 12 volts. Oh, sorry about that. Hard to do with one fan always, right? Okay, so I connected it. We are starting right there. It will take a little moment and it will go online. I will need to go and set up all the mining settings if it's not set up yet. But I'm gonna show you my solar setup that I use in 5 of these ultras. That previous fins, see, like these fins, notice like this on the special edition, commemorative edition, we had those extras similar that we have on those KS0 originals that I still have in this mining box that I need to get rid of probably and put ultras, all 6 ultras in here eventually. But for time being, I'm gonna be doing the test of this bench over here with the 6,000 RPM fan and compared to my other setup right there. It doesn't start going. I hope it's everything is fine with this miner. 7. I think it was before online already. Oh, okay, it's got it. It's got it. All right. All right. So here on my solar mining, I already have this Ultra number 1 set up on the solar. Right now it's mining on the pretty cold. It's probably not gonna be, because this fan is on, you're gonna see the hash rate is lower because it's pretty cool to touch, so it's not warm enough. But look at the power consumption of this first Ultra. This is number 1 right here, 87 watts, guys. That's amazing. 87 watts have been mining on that. The other unit here, number 2, also not overclocked, mining 99 watts. So the difference is 12 watts on the stock firmware, which is crazy how much different they are. They're same batch, same unit batch. You could see, oh no, look at that. Their fins are bigger. Those are smaller fins. So this batch with the smaller fins, potentially they taking less power, maybe. I don't know, maybe just that unit, but anyways, look at that. This is with the multiple fins, and that's where I had the trouble. When you remove the board, it's unscrew, all your board will unscrew together with those stands. Anyway, let's start overclocking this. It's mining on the stock because all these 5 units on the solar mining on stock, because I have only 500 watts on solar 24/7 available for this setup. All right, so you notice the Ultra 09, just remember it's number 9 miner will be on 19 or 20 volts. And this is the shroud I'm gonna add after I start overclocking. I wanna show you the power usage with the, using the full 400 gigahash hash rate, right? So 107 watts and 87 watts for 12 volt mining directly on the 12 volts. So that's what I got so far. So let's go and start overclocking. By the way, I forgot to tell, I use this veteran miner cable, which is really great quality, to mine on the stock firmware on Ultra, and this Ultra been mining no problem. There is no damage to the connector. It's high quality, but do not try to overclock with this wire. Even though the wire may be capable of holding up overclocks, I don't know, it's 16 gauge, it's not that big, but I'm using 14 gauge silicone, which could handle, I think, a lot more. So we'll see. Let's get to it. All right, guys, we are in the web GUI. So as when you install the new Iceriver Ultra, KS0 Ultra, and you get this machine is offline message, you find your IP address, everything seems to be fine. There is no info here. However, it lets you set your mining pool, so you can still set up your mining pool. But if you go to here to home, it will be machine offline message because you need to update your firmware. And if you were on the network more than probably 5 minutes, it basically records as machine online. And if I even click the new from Iceriver website, you can get this new update. I'll show you where it is. You go to the Iceriver.io. All right, and then you go to boom, it's right now, it's probably here. Support, repair, tutorial. Okay, they moved that stuff around. So okay, use that link tutorial at the very bottom of Iceriver.io website here. When you click tutorial, you'll have product manuals. You scroll down and this is your firmware downloads. As you go, select your machine Ultra. Okay, if you're doing for Ultra, download it here. So once you click download, it will automatically bring it up and download the latest one, 3.2.15 KS firmware. You have to unzip it to the folder. Okay, so I already done unzip, and now just to guys to let you know how to sometimes there's a lot of posts like how you can reconnect. So when you have machine offline, you can probably recycle power reset or cycle power basically on your machine, and then quickly go back here and update firmware. But if you waited 5 minutes, look what happens is I'm gonna click select the right firmware, click update, and it's gonna say the machine is not connected. So I figured the easy way is the only page is the IP settings, and mining settings is kind of connected. I'm not sure about user settings, but if I click here and do refresh, so now it's still gonna say machine offline, but what it did, it basically went from here and kind of refreshed the page. And now if I select the firmware updated from Iceriver and click update, now it will update the machine. See, it's no problem. So this is a little trick to do it. Just go to the mining settings and then refresh your page here, and then go back to firmware update and update your firmware. After you update firmware and restart the machine, machine is going to be online, so make sure you do click OK and confirm restarting machine and get it operation succeeded. Okay, so after the machine restarted, see, even though machine was not visible on the web GUI here, I was able to pull same IP address on Iceriver monitor tool, and I would get 355 stock firmware. All there, it shows everything here online, and it's mining. So if you go to mining settings, change the pool, machine will mine, but you're not going to be able to see your stats here on until you update your firmware, or you do IP settings and set up static IP, which a lot of people don't recommend, because if you set up static IP and your router it will be taken the IP address for any reason, it will be conflict of IP if you have the static IP and someone else or other, if you need offline and you would get your phone connected to the same IP or something like that, then it will be conflict of the IP because it will not automatically switch to the new IP. Anyways, so after the miner restarted, now you're gonna see everything here, the new updated firmware. And you can simply go back and change your pool address and stuff like that to the pool you want to mine, which in my case I'm gonna use I use Humpool for the KS0s. Pros and ultras, it kind of worked out because I can set up multiple accounts under one account. It makes a lot easier for me in that case. But let's see, and I'm using this miner. I'm not sure what number it is. I believe the one I just connected, it's number 10. If not, I will change later, but I'll just set to the number 10 of this 6 ultras. That's going to be overclocked and save. All right, so after you do that, sometimes if you didn't change the pool, you will have to change your restart the miner, but it will automatically sometimes take that pool if you're changing the pool address completely. So we'll see if it appears. It will appear here on the pool under my workers here. Hopefully it will be here. It's under different account here, KS0 Ultras. I set up 6 of them right there. And so it will appear eventually here under number 10. Number 8, I disconnected to make update to my Heatsinks and everything there. So it's this guy has been online. So we will be working on this number 9 unit, okay? So number 9, we're gonna overclock. So watch the hash rate 24 hours, 405 gigahash. So it's been running pretty stable, 405. And remember, it's on the 19 or 20 volt PSU, right? So, and 108 is the power consumption. So what we're gonna do for this video, I'm gonna just simply go and create a little Excel spreadsheet, and we will just add this little nodes here. So we will do we'll do 2 of them because we have 2 of them, right? So I'll be trying not to do oversize here right there. Okay, sorry about that. I have to record my screen for this video. Okay, so I have KS0 Ultra and this one is going to be 01. That's on 12 volt. And the second one will be number 9 on 19 volt, or we will call it on the, it's actually on the 20 volt, but just for this video we'll put it 19 volt because that's the power I use it usually. Okay, so and then we will use here on the first column we will put the clocks, which is the stock firmware. So this will be a firmware, and this column we're gonna use for the hash rate. All right, so I have to move this a little bit further, and this way we'll have 3 columns on each, and this will be for power consumption. Remember, this is on the 12 volt usage, and this one is on 19 or 20 volts. All right, so this is our spreadsheet. We will insert the power for each clocks, and hopefully so what we have here is the both of the units on 12 volts. So let's go back and check here. So on the pool we have 405. So let's average to 400 gigahash right on this unit, and it's not overclocked. It's the number 9 right here. It's 69 IP address, right? Gonna add the IP as well. IP 0.69 so we don't get confused. And then it's running on the 19 volts, and we have 456 here hash rate average for, okay, so see it's fluctuate a lot. So 416, 382, so let's call it 400 average of the hash rate. It will be good enough, I think, right? 400 gigahash, and that's it. And now we go to our the IP address. We want to look for the second unit, which is right here is our second unit. I'm gonna put two screens so we can do side by side, and I'll show you guys one firmware, and then I'll be keep on going and update at the end with all of the result that I got, or maybe in the middle of the video I'll turn it up and I'll show you some power consumption and so forth. So let me update. And this one going like 417 average, this one 416, 30 minutes, so very close, the 30-minute average. And on the pool, this number one doing 396.8. So this a little bit doing better, 405. So let's just get the data. I'm not going to be able to get full data from pool because it needs full 24 hours. But what I'll do, I'll be doing just the power consumption and what I'm gonna get in the web GUI. So I'm gonna be using the hash rate 30 minutes. I'll let 30 minutes for each firmware to run, just to be fair. So we have 30-minute average, or maybe 35. So we get a good average there. And this is number 9 and this is number 1. All right, so let's get back to it. I'll start updating. I'll show you one in a second. All right, so before we start overclocking these two units, I want to show you on the Iceriver monitor tool how this first one right here is running on the basically on without any fan, with the fan. Actually, if you remember on solar here, I had that shroud by Fruition Design with the fan on the lowest speed, but it's still cooling down the chips to 4953 and the board 5143, which is crazy. But if you look at these temperatures here without the fan, that's the one number 9 that I showed you there on the counter, it's actually running almost 20 degrees hotter everywhere. And but it's both of them performing pretty much similar in average, to be honest. Is this one going around 409 and this one going around 415, slightly higher, but the rate is kind of fluctuating a lot. So this machine, number 1, is maybe performing a little bit better because also it's using a lot less power at the 12 volt compared to my other on the 12 volt using about 10 watts more, I believe, like 95. I'll show you guys. It's, well, with the fan basically right here. So we're gonna have this information right there, which I can zoom in for you and show you that what we have here right there. 87 watts for the first Ultra right here on this Fruition Design, right? And 99 watts on my second one right here. But I don't know why there is a fan connected to the second, so we can measure the power usage of the fan, but the fan using only on the lowest like 2 watts, maybe 3 at the most. So this one 97 and this one 87, so 10 watts different on the stock firmware. So it's a huge difference, guys, right there. That's what I noticed. So, but I'll be testing this high efficient machine just to get the idea how efficient we are on overclocks. And so before you start overclocking, guys, make sure you close. You can stop, but I recommend even closing so you don't forget, so you stopped it. So make sure that 64 IP, see, like 64 IP, I stopped reading and stop here. I would prefer close both of these Iceriver monitor tools to be safe, because it's very important. At some point you can get stuck with the firmware upgrade on the initial, and if that happens, I'll show you guys how to potentially fix it. So first we're gonna go and find the Dev Ultra. This is the KS0 Pro and this is KS0 Ultra. Now Now you have to be super careful with the KS0 Ultra. Do not try, if you try any other firmware, you can potentially break it right away. If you purchase firmware, you need to use only for your MAC address. So first you have to start with the initial update. So we go and get the initial file right there. And this is really important that your monitor tool is closed. If you didn't close your monitor tool, potentially what may happen, you're gonna get error message or like it's failed, or worse, it will not fail, but it will not take the firmware, and you won't be able to update your Overclocks firmware. So it's kind of weird reaction to that monitor tool, but yeah, make sure you use a proper KS0 Ultra. Okay, so don't use different firmware because that's the risk. Okay, and then we're gonna click update. So we're gonna scroll out there and update that firmware. So hopefully there is no issue with this one, because we had a monitor tool open on both of these units. I closed them off, but if they open, sometimes you get the message that it's failed. So the second option, if it's failed, make sure you close, if you forget to close the monitor tool, and try it again. If it fails again, do not try to factory reset at that point, because you will break your machine. So very important note, I already bricked one of my machine. Okay, so operation succeeded on initial, and we're gonna click OK and restart the unit, and we're gonna restart the second as well. So we're doing this almost at the same time, two of these units, right? Now, if you do the failed message, there is an option. Option number one, using the Iceriver management tool, you find your device IP address. So let's say we're talking about 64. You set up your 64 here. I have 64, so 69. Let's say just like that, and save. Okay, so you can scan only these IPs, and then you can go to upgrade option. From here. Okay, so you could do all of this. So 64 restarting, so we cannot see it obviously until it restarts, but once it restarts, it will show up here. And yeah, so we don't have anything right now. The machine's still restarting from the firmware upgrade initial. Okay, so once the initial restart happen, we will see the machines here. So let's wait till it starts. Okay, it looks like it just started here, barely 7 seconds. Okay, so it will now see on this, if we start scanning, it will show up 64 and 69, both of these miners. And the next step would be so I have two of these machines, right? So in case they failed to update initial, you can go to upgrade here and select this two of these miners that I have to connect them. See, they're two online, and from here you can upload your firmware. You can add the firmware like I had it here, initial update, and you can try to update from here. If it's gonna get the same message failed, that means your monitor most likely tool was open, and that creating some sort of a breach. So don't try to factory reset, because at that point you can potentially break your miner, and it will cost you to repair remotely, okay, with the Tswift. So now the next step, what we did yesterday, is actually, instead of going and so if it doesn't take your firmware, right, so we would go back here and do the revert update file. At that point, make sure your monitor tool is closed, okay, and do revert update, and typically it takes that file, it did for me, and then I start initial update over again after that. So don't mess it up. Make sure follow those instructions as in the read instructions very careful. But something like that happened. It did happen to me. That's the way you probably should do that, how it worked for me. Anyway, so since we did successfully updated our initial, so now I can go to 505 GL. on both of these miners. So we're gonna select 500 GL, and that's a low voltage, which use a lot less. About, for me, it's almost 20 watts less than the G version. I haven't even tried high version. I don't know if I want to try for this video high version, because the sounds like the L version works fine, GL, and then the G works also fine, but GL perform a little better. And if you're lucky enough with your silicon, then you'll get your better power consumption efficiency, basically, right, on the mining. So let's update this to the mining. I'll give it both of the units 30 minutes to work, so make sure it's restart the machine, confirm the restarting. Now, if you're running your machine for the first time, you need to set up your pools once it's restarted, or you can set your pools initially, and then after you restart, your pools will not be reset. You will still have your pools ready to mine. So at this point, I'll be waiting till it restarts, and then we'll go back and get our Iceriver monitor tools open, and so it's pretty much safe. After you update it and restarting, we can get those monitor tools. I'm just going to show you at the first quick look, and then we will go back and wait for 30 minutes, 35 minutes until we get full data for the mining power usage and the hash rate. Okay. So I didn't select Ultra there, and that's not a big deal. So we can go back here, select Ultra, Ultra selected. Okay, perfect. So now as soon as it's gonna go back online, we're gonna have it right there. It's not gonna show your clocks right away or temperatures until probably, see, it's only 9 seconds. So it may take about usually 1 to 3 minutes before you see clock. Sometimes it's sooner, but it will take, so 355 were the stock firmware. That's what we probably should add there somehow. I added the efficiency here to their spreadsheet, so we can have some data for efficiency of each clocks. But also it's the stock are 355. I may just gonna add the clocks here, because it's kind of confusing which clocks is there. But what's cool about the new firmware now, it's when you update it and you start mining with the new overclocks. So I'm gonna refresh it here. At the bottom now, you're gonna see what type of firmware you are running. I'm gonna tilt down a little bit and zoom in so you could guys see it right there at the very bottom right here. It says actually the Tswift K0U505GL. So you know exactly on which firmware now, which is a pretty good update, I think, for that. Thank you, Tswift, doing that with development team, because it's really helpful. Before, you have to open Iceriver monitor tool, and even if you open monitor tool, you don't know if it's a L version or it's a G version. So it's still really confusing. So you could see now here, it's even right there in your monitor tool, 505GL. So you know exactly what version you're running, and now you see the clocks are 450 for 505GL, 505G, and 505H. It's always going to be 450 clocks. So it will be hard to guess only based on the clock. So this is really helpful when you have it right there on firmware version. Okay, so let's take a look, both of them using the right firmware. We don't have accepted shares yet. It's been only 2 minutes, so yeah, we'll have to give it this video will be probably super long, sorry about that, but I want to record as much information as possible with this modding and trying to get all the clocks here and all the power consumption, and hopefully this unit can take higher power consumption. Now I'm not gonna change the fan speed on this. I'll show you what the power consumption now here on number 1. If you remember, with 87 watts, it jumped to 122 watts. We'll start mining, we're probably gonna be around 123, 25. I think, my guess, I can't remember, but we will update this here on 12 volts, and then I'm gonna go and run and check the power consumption on the 20 volts. I don't have camera there. I should have set up another camera, but maybe I will, so we'll see. I will still have to wait 30 minutes. We'll update the power and the hash rate here and the firmware clocks. So maybe I'll just put the numbers here and the clocks here, which is 450. I'll just put clocks. So it will be kind of easier for us to figure it out. Okay, so 450, and we will be doing that just right there. All right, cool. So I'll see you in after we have the full update. 35 minutes or so, and I'll update you guys on the first firmware, and then I'll keep on going and getting the data for you. All right, so it's been 45 minutes. We have 148 watts here at the wall on this power supply, 20 volts. Let's check. Meant to say 12 volts, so we are actually running about 13 volts because it's during the day the battery charges up to 14 volts, so but it runs out to 12 or 11.5 volts when it discharge. So at 13 volts we have 123 watts, right? That's my number one running over here with the Fruition design and 6,000 RPM fan. So my first actually doesn't have fan, and this power is not counting the fan. Fan is connected to this power supply at the second unit, only using probably 2 watts because it's at the minimum speed. So let's take a look at some of the data here in temperature. So my first unit with the fan, look at how beautiful the temperatures are, so low. It's taken 521 gigahash on 505 low, which is really good, I think. And the temperatures on the board is 5945, which is really low. Where here we have 6852 without the fan, which is also not bad. But a lot higher temperatures on the chips right there. So you could see it's almost getting to 90. And I believe the ambient temperature here on the 19 volt there in the room is about, it's not that hot, it's about 75, 77 degrees maybe around the miner. So you have to keep in mind when you start overclocking, and look at the here the overclocks. I maybe because it's a little bit hotter did not take the full hash rate, so this 12 volt unit doing a lot better for me. Maybe just silicon or not, but I'm gonna have to put the fan here, and when I update the next overclocks, because it will be a little dangerous without the fan going with that temperature. Let's look at the web GUI and see what we've got here so far. So yeah, about 480 for 60, and it's 485 and 521. Yeah, so it's a quite bit of different, almost 40 gigahash in 30 minutes. Obviously in 30 minutes the rates will fluctuate. It's not enough data to go and check on the pool, unfortunately. We're not gonna see the change yet on that. If I update here number 9, let's see. Yeah, it will not give us the full update. Even 1 hour, it's still like under 423, 430. And about same we will have here. We're not gonna have this number 1 running at the yeah, we don't have the 500s here yet. So anyways, and look at the stack firmware. Oh, number 7 is actually running on the 505 as well. And you can see been running for a longer time, so the average almost got the 500 watts there. So I need to check that power consumption so we can track one more miner there as well, just to have the better data on the 12. This is on the 12 volt, and it's actually running on server PSU. This way I can measure how much it's each clock's added to the power supply. So when when I restart it, I will see what the power consumption before it takes the the power, and we'll see how much extra we adding to this unit. So at this point, we are going back to number 9 and number 1, and we'll be going to next overclock G. It will take a pretty long time for this video to do every single clock, so I will just keep updating every clock here. So right now we at 5:05, we got pretty good data here. 5:21. I'll just put 5:20. Obviously, it will adjust after several probably hours or a day or so, and we got 480 here on this unit, which is just probably not long enough to get these averages up to the right space, but at least we have the power consumption 147 versus 123 watts, so it was about 30 watt difference. Now it's only about 25 watts difference. Interesting, right? So anyways, we'll keep all this data here, and we'll keep updating the but look at the efficiency here, 423 on the, so it's a little bit lower than the stock firmware, obviously, but it's still pretty efficient here on the 12 volts. All right, so let's go to the next one. I'll get this list updated. Maybe I'll see you somewhere in the middle there. I'll show you a few screens as well. All right, before I go further, so I updated the firmware again, and look, they got the message failed here, and one was actually successful operation. First time it failed, but I think the real reason I forgot to turn off this, stop this Iceriver monitor. So very important, guys, stop it or close it altogether, and because it will get you possibly this message. So after I close it, let's hope I'll refresh the page, go back to firmware update here, and let's hope this time it will take 505G, because it did kind of react differently. Cancel update. Okay, so let's see if it's gonna fail again, but this says operation successful. Let's restart the machine. A lot of time when you have, after you have first firmware overclock installed, when you go to the next one and you don't close your monitor tool, sometimes it says it's successful. See, like this time it's okay, but this machine probably did upgrade it, but it will not actually change the clock. So we'll see that in a few seconds, and you will see what I mean, because on this specific unit, it did take firmware even with the open Iceriver monitor tool, but after its restart, it's possible that it's going to keep 450 and this will go to 460 or wherever the next clocks are. So we'll keep an eye. We'll refresh there in a few minutes once the unit back to online after restarting. Yeah, I'll be right back. All right, it's not the clocks is not gonna change because it's the same 505, but it's a G version. If you see here, I'm gonna zoom it in there so you guys could see. So this firmware took to 505G right here. Okay, and on this unit, even though it's confirmed after restarting, it's still showing 505GL. You could see it right here. So just be careful when your Iceriver monitor tool is open. You technically can get confirmation that miner updated, but it's not. It will go back to the same. So I will have to do it again. And now with the Iceriver monitor tool off, now I can get to G version and slide it and select update. So hopefully this time, so see, like this one is on the G version, which is going to be a higher, potentially higher wattage there, but 20 watts. I noticed 10 to 20 watts difference on the 12 volts. So we'll see how it takes that, and hopefully it's okay and it will restart and we'll get to that G version over here as well. So we'll be back after it restarts, about 30-40 minutes. Maybe one more time, and then I will update the list, our Excel spreadsheet with all of the data here, and we keep on going on that. just to get the information for the rest of the list. I need to fill in the rest of the clocks here, and we'll see you in a little bit. Alright, so we see that we have a highest temperature of 80 degrees there on our heatsinks now, with the 680 high GH version. So the temp gets really hot on this heatsinks, a lot hotter than we've seen. Oh, look, it's going almost to 90. I wonder if it's going to shut down the miner or not. So let's look what we have on the webplate. And I have about 103 degrees. This is crazy. 104 on my other one. So yeah, getting ridiculously hot. 105. I definitely need to increase the fan speed here as soon as possible. So let's get it to the low. We're gonna drop the low to 38. So hopefully that will increase the fan speed to, okay, so it's 3000 almost RPM, 2800. And the ambient temperature 79, so it's not very cold environment. So let's see what we're getting in terms of the heatsinks temperatures. Okay, it's dropping to 194 degrees highest, 99. Alright, it's still kind of hot, but it's lower than 100 now. So let's increase even more. Let's get this I'm gonna get to 35 and see where we have. Alright, so we are at 3400 RPM. And notice that our power consumption about 2 watts extra, so we probably about 6-7 watts now on the fan. 3000 RPM now because temperature dropping when we increase that, so 36. Okay, so let's check it out. Let's see what we actually can get there. Alright, so the temperature dropped a little bit. It looks like we are down to hottest 80 degree, much better, right? Yeah, close to 80 degrees, guys. Alright, 76, so let's check it out, the other one. Alright, about 84 degrees on this heatsinks, and with the fan at 2000 RPM. So let's increase this fan to get down to 38. Alright, so we'll run the fan at 3400 RPM here. Let's see where it's gonna get us to the running about 84, 83. Okay, so it's 82. Okay, so it's dropping a little bit. Not a whole bunch, but it's better. It's lowering with the fan speed. It's going down towards 79, which is good. All right, so let's see if we increase the fan even further. So I'll drop the temperature here to the 35 point. So we are at 3800 RPM now. 3800 RPM, and the max temperature here on heatsink 75, 74. So yeah, you basically keep it cooler only when you're blowing more air through this heatsinks. But my guess is we're gonna get the unit cooler, so the chip's gonna get a lot cooler, and possibly the hash rate gonna drop. So let's see. Okay, it looks like this one is just shut down. It probably was thermal throttling, and I didn't notice that point, but on the H version, on the high version, going over 200 watts, it just restarted, looks like, right? So the power went down, and probably on the stage of restarting because it's all cool now. So definitely not enough with the small fan, need to upgrade the fan to the higher RPM there. Now we're going to 676G. Let's go check the chip temperatures at the, what do we have so far? We have the 4200 RPM on this fan running right there. So I want to check the temperature on the heatsinks, ambient temperature 80. This guy running at, let's see, 37 degrees, and it's 2500 RPM. 2500 RPM, so it just started, and the temperature's here already 70. So typically it's already double, 20 degrees more there on the heatsink. So it's possibly that the temps here already at the 90s. So it may gonna shut down, or well, let's see if it will increase that. Potentially it goes up and increase the temperatures. I mean the fan speed on this manual. Yeah, looks like temperature is rising, so it's 28, so going to 3000 RPM. So hopefully, and look at the power consumption here, 240 watts running there, but let's see on the temperatures here. Oh yeah, it's rising. It's gonna shut down the unit there at this temperature. It's over 100 now, so let's need to change the fan. So you cannot use the simple 1400 RPM fan. You need to go 3000 or more RPM when you achieve that overclocks. All right, so I have this fan running at 4000 RPM. The power consumption 206 watts there. I don't know if you could see that on the screen. It's kind of blurry. 206 directly on the 12 volts. Plus we're using about 8 or 10 watts on the power consumption of the fan running this speed. So, and our temperature here is showing 60. Let's check the MOSFET, the heatsinks temperature real time, see what it is. And I'm wondering if I'm gonna, so the fans are 0. What if I add the fan speed here, and let's set it up to 100, see if it changes anything at all. So I'm gonna go to mining settings and put 100% there. All right, and click save right there. So I just added 100% there, and let's see what do we have. So it will, okay, so it's showing 625. Okay, 500. So that's the full speed. So let's see if this board temperature is gonna affect anything, or if it'll help anywhere on these sensors there, and how the chip temperatures will be affected by the fan speed. So let's wait a few seconds and see if 6042 anything changes here. Yeah, looks like it doesn't change any of that temp. So let's go and measure the temps on this board. Looks like my board here just restarted, so it's not enough running on 2000 RPM, even 3000 RPM not enough. So it just dropped because it's overheated the heatsinks, the MOSFETs. All right. So this is really important, guys. When you're running, you start to run over 618 GL or G, you have to have the more efficient cooling, not just heatsinks, but the some kind of shrouder with the fan capable of cooling down this heatsink. So far this is the only one is running on 4000 RPM. I put all this to 100% blowing. This internal fans 100%. Let's see what we have with something happened to my cameras there. I need just to go probably and physically check for now. Alright, so this is the only one that mining, so it's around 69 degree on this hottest spot of those Heatsinks. 70, see the 70, so it's pretty high, but this is the only unit is actually mining because it's 4300 RPM fan and 80 degree is the ambient temperature right there. So yeah, and it's, let's check it out. What's the 40 degrees is Celsius is on yeah, 4200 RPM. So we're running 4200 RPM on this fan. It could go up to 5500, I believe, but 4400 it's cooling to 70, so we can still increase a little bit of the fan speed, but it's gonna cool. The unit's super cold on touch, so it's cooling down the chips more than it needs to, so it may not gonna perform the full hash rate. But it needs the airflow through the miner, so it's really important just to get the air as much as possible through the inside. So maybe it's actually was a good idea to remove these internal fans and put it outside, so I need to try that too. Alright, so it went to 105 degree on one of the heatsink. I think it's gonna shut down the miner, so it's 106. 107, and I have the fan speed running 4,000 RPM. Let's try to increase to 5,000 and see if that helps anyhow. Okay, so it's 5,400 RPM. Let's see if we're cooling down any less. Okay, so it's 103. 105, so it's still super hot on this MOSFET, so you really it depends if your MOSFETs can take that temperature or not, because it's 105. I think it's kind of high. 110, gosh, it's gonna shut it down probably for sure, and it's keep on coming up to 112, so it's super hot. Yeah, I guess it's just super risky to go on that level of heat. 109 degrees. It's still mining, looks like, because once it shuts down, it will just cool down completely the unit. Sorry about the reflection. Yeah, it's 110 degrees. That's just crazy compared to the other unit is about 79 to 80, so I'm not very happy with this temperature. Maybe this specific miner will not take that temperature, and I'll have to reduce the hash, the other overclocks, just to make sure it's safe for the MOSFETs, because yeah, for the long term I don't want to run 24/7, especially it's going to warm up. It's still kind of cool, 80 degree, but it will warm up to 93 ambient temperature, 95 today, and it will definitely overheat this heatsinks at that point. Alright, so I switched this fan to 6,000 RPM fan, and let's check it out. It just started mining, I think. Let's see what's our temperatures. The highest 70 already. Trying to aim on those heatsinks right there. So highest point 73 degrees, guys, and it just started. So let's give it a few minutes and see when it starts mining. So it's kind of rating up 75, 76, but still better than 110. So let's see if it's going to increase after mining for maybe 10 minutes, and I'll double check that. Alright, I have 80 degrees here on these heatsinks, 80, a little bit over 80 to the hottest spot right there, right? But I did a little modification. If you can see that tape inside, these fins on the other side, so all the air just concentrating to blow inside this miner, and that helps, hopefully helps drop the temperature. So it looks like it's below 80 now. It was going over 90, so let's keep it mining, see how it works, if that helps a lot or not. So it's over 105 degrees here. I don't know if you guys could see it on the hottest spot. So it's still a little bit too hot here. 111. Oh my gosh, yeah. So this unit running really hot. Looks like the only one I have is that solar unit that it's still, I'm running at 4,000 RPM, I believe. Yeah, 4,800 RPM. So this just, I need to more concentrated air through the middle. So I'm making a just mask and tape these fins from the other side where the air blows to help to concentrate the air like I did on the other unit. Alright, this is what I done for this modification. So I pulled the fans out. I didn't have a spare spoofers, fan spoofers that I could simply just put in, which I probably should do. This is temporarily, I just cover these holes for the better airflow, and then I tape it all out around this area so the air would just blow right into this unit, into the heat sinks. Alright, so let me put it back there, power side in, because it's going to be closer to the those yeah, I think it will be closer to the other side. So let's get it, put it back and see if it helped temperature of these heat sinks or MOSFETs. Right, so unit back, and I have my two diffusers on the side, so hopefully the airflow will just concentrate right on the middle, and let's measure the airflow there. So I have about 10 miles per hour on the middle here on this unit, which I taped only one side, so let's check the other. Alright, so on this unit I only have 4 miles per hour because it's still low. I only have the 1700 RPM, so let me increase that rate actually. Let's go 25% minimum so we don't run too low ever, right? And here we are, 2600 RPM now, and we're not running. Okay, so it is 6.4 miles per hour on this wind blower. So let's all right, I just started this miner. The fans are off. I'm gonna leave them outside. They'll probably need to be connected most likely because it will not report the fan speed, and it will just turn off the unit. So yeah, and they're not even powering on. I don't know how they're reading the speed anyways. So we're just starting up. Now we can clearly see the heat sinks right there. So let's check it out when I start mining, what the temperature is going to be. And once it starts heating up, we're probably going to see a higher wind here because it just running at 6 miles per hour because our fan's still 2500 RPM. I will increase to 30% probably right there. Okay, 3000 RPM. To start point, and then it will increase as the temperature will rise. So it's about 7 miles per hour right now, 7 miles per hour on the middle of this fan blowing. Yeah, so the other one is 10 miles per hour because they have probably running at 4000 RPM, but this fan will increase as soon as it sends higher temperatures. They have a sensor just right here, slide it in. So we want to make sure it's controlled so when it's a cooler environment it doesn't blow unnecessary air. But however, we may need extra air even with this overclocks, even with the cooler temperature, so we'll see. Alright, the temperature starts rising on the unit, so the RPM of the fan 4700, 4780 RPM, and we're getting about 12 miles per hour. So it's a lot better wind concentration, I think, and as the fan speed will increase. Oh, it's already 5000 RPM. Okay, so 5000 RPM. Let's check how much air is blowing through here. Okay, so yeah, we do have over 12 miles per hour. So getting close to 13 miles per hour here, which is pretty good, I think, overall. Let's see how the Heatsinks will handle this, the temperature of the MOSFETs with the open area here without the side fans. I put them on the side here, okay? All right, before I'm gonna go back and check temperature on this heatsink. So this is the last unit, the one that I removed the internal fans and modify here, tape it all around so the air kind of concentrated inside. So you could see how cooler this temperature of this board in, showing 53 versus this one is 63, the one that I also taped around. And these are the helping the actual chips temperature to stay higher. Since I taped it around, this chips didn't go higher yet, maybe because it just started to mine. So we'll have to give it more time, like an hour or so. And take a look at these temps right here. So this one is on the solar. I didn't remove the fans, internal fans, and I didn't tape it around. It was keeping the temps a lot cooler there, but look how much cooler are the chips. So it may not gonna achieve that full 600, although the average showing 666 G, so it's closer to that 670 version, 676, right? All right, also keep in mind the temperatures you see here on the mining Iceriver monitor tool. It shows 58, right, the board in and out. So the actual temperature on the heatsinks, what I noticed, our MOSFETs are about 10 or 8, between 8 and 16 degree higher than what you see on the sensor. So you have to be really careful by, if you're looking at 64, like right here, it's I'm running around 80 degree already here. So if it's 70, it's kind of like close to 90, maybe 95. So just to give you guys idea, and we'll go and measure this one because it's staying pretty cool, 53 degree. It's not been obviously full hash yet, so we'll see, because the chip's temperature is still kind of low, the lowest of these three, so we need to give it more time maybe, or we running like 5,000 RPM, maybe way too much cooling for the chips. But I may be able to put here 700 GL version also to try it out. So first I want to check this temps, how it takes on 676. Obviously it's a G version, so it uses a little bit more power. Like what you see, it's already 207 watts on 12 volt directly, plus another 15 watts on the power of the fan that blowing 4900 RPM right now. So, and we have what do we have on the power here? Okay, so this is messed up. I need to adjust this camera somehow right there. I can. All right, so I'll have to adjust this camera so I could see the power usage on this unit. But other than that, it's we need to just measure the temperatures on this one. It's start rising a little bit on that last unit that we taped around, removed the fans, but a lot, looks like it's a lot happier with the internal fans removed and concentrated the air inside the unit. Look at the temperatures. That's the coolest so far showing temperatures. Let's check it out and see how the actual heatsink. So remember, it's 54 on the highest temperature here on the board. So let's check what's on the actual heatsink there. All right, so I have about 64, 63 degrees on the highest of the heatsinks temperature, right? 65. So it does increase when I reduce the fan speed. Right now at 50, right here, 5300 RPM. 5300 RPM. So if I reduce, I try to reduce to 4500 and I start growing the temperature, just keep on going to 70 degree. So I think I will keep just at 4500 RPM and to be able to test the next firmware. And it looks like it's cooling down a little bit at 61, which is great, although it's going to keep the chips a little bit cooler than we need to. So let's try the 700 GL on this unit, see if it's even going to take it. And the wind speed about 13 miles per hour, 13.3 sometimes. So it's kind of like, yeah, it's higher than we did on KS0 Pros, but it does help concentrate the air on the middle. On this unit I have about 67 degree, the highest, and the fans, internal fans not removed, and I'm running about 5000 RPM on this fan, and I didn't block the area, so it's not concentrated. So the chip's getting a lot cooler because the unit's really cool to touch, okay? And this run the hottest of all, 80 degrees here on the highest point of this heatsinks, right? Whatever I could get to, 80, 81, all right? So pretty higher temperature, but it still mine's okay. And I haven't removed these internal fans as well. And RPM is about probably 3000. I may need to increase a little bit. All right, so let's see if this is gonna help to reduce the temperature. All right, it's still around 80 degrees, so looks like slightly maybe reducing, yeah, 79, 77. Okay, so it does help. It does help the fans blower. If you increase to like 4500 RPM, it does help to drop the MOSFET's temperature, right? Let's go back and see where that was. All right here. We are at 75, 76. I'm not getting that specific. Yeah, so it looks like it dropped to about 75 degrees. It's really hard to do it. Just you need to point it right there into that heatsink. 73 degrees on the hottest point right there. So it did drop from 85, all right? So it does, looks like it works a little bit better, okay? So you do have to have a high flow fan on that surrounder. All right, guys, so I'm back to computer screen here. So we've been running over an hour on the last machine and 2 hours on the first one, and we've got to 664 gigahash, 59 degree highest here on the board, 54, 63 on the chips, which it's a little bit cool, I think. That's why we can't probably produce a full hash rate, 670 or 680, but it's still pretty high. But if we look at the temperature of the chip, is about 67, I believe, close to 65 or 67 degree. All right, and then over here where we have this miner on 20 volts, looks like the chip temperature is a lot higher, but our it's showing here is a lot lower, 59 degrees on the inboard temperature, but on our heatsink is actually 75 degree. So here is how is the temperature difference here. We have about 67 here, 75 here, but it looked the same on this monitor tool or the board temperature web GUI. Gonna show you this 59, 59, and your real temperatures could be a lot higher on the actual MOSFET. So just be careful, guys. That's why I want to kind of concentrate on this last overclocks, the 676G, and then we go to 700G L and hopefully G. There is no G high for 700. And for this one is obviously, if you don't take 700, this kind of, you have a good chance on using this 600 clocks there. And take a look here. We're getting like 731 here, the highest, 681, 657, but in the average is still pretty good, I think, 664, 691, and 671. So very close to where we should be. So I think this is the best readings because of the higher temperature on the chip. So somehow I need to block more of the air from cooling down the actual unit, the heatsink of the unit, not the small heatsinks, and try to cool this one down more. So that's the main goal, probably try to concentrate the air. So there is a lot of shrouders that may just very narrow, that it's pushing air only in the middle, and it will allow to heat more on the on your chip's temperature. Okay, so then between like 60 and 70, you're probably sweet spot there, as you can reach like the higher hash rate. Where on the lower sides are even like there, it's a little bit lower, 671, although it's kind of interesting because it's a lowest MOSFET temperature. Here is like 63 degree, and we see in here 55. So that's it for this part. So let's go to 700 clocks. So I'll be updating to 700. We'll get few shots. So let's check real quick the power consumption on this unit. So just to get you back to, to this unit. Okay, so right here we have 236 at the wall without the fan probably another 10 watts. So if you're using with the fan, you'll probably gonna run around 246 or more watts, something like that. So we'll update our spreadsheet. So we're looking about 240 most likely for these clocks. And also the 93 ambient temperature doesn't help. It's quite hot there in the room. So now where I have 207 with about 17 watts on the on my fan's temperature, I mean power usage. So it's total about 224 on this setup on the solar. If anyone doing the solar, trying to overclock for solar mining, it's the most efficient because you are directly at 12 volts. So right now 13 volt you noticed, and it's about 16, almost 16 amp. So there is no way you can use barrel connector. I use this this XT60. So right now this one not overclocked, but there is XT60 there on the back, directly soldered to this unit on a 12 volt that I run directly from that from my solar usage from here, the negative and the positive running here. And this is a 10 gauge wires, I believe, and then I run to the splitter, and I use to power up 5 of my miners. Okay, so anyways, I'll be starting overclocking now, and you see like 5,000 RPM, 5,200 RPM for this fan. I have 5,400 RPM on this fan, and probably about 4,500 to 5,000 RPM on my on a 20 volt system fan, which adds another like probably 12. I will use 12 watt for this setup so I can update my spreadsheet. So far I almost finished, so there's few more items to add up there, and we'll be going to 700s after that. Alright guys, so I'm about to finish this longest video, but I want you to have as much information as possible, because I have these 3 machines set up on the different settings, which one is on the solar 12 volt directly, one is on the 20 volt PSU, that is 330 watt PSU, and then one is on the server PSU, which uses also both of them 12 volt using the XT60 connector. So don't try barrel connector on any of this overclocking past 505 even, because I already have burned one of my barrel connector at 505, I believe, or 562 GL. So just be really careful, because as you start going, you're jumping up to 142 watts there, and 23 watts, so it's over 10 amps slightly. So you potentially, if your ambient temperature high, you potentially can burn down your barrel connector. Okay, so anyways, for this video, just to get the conclusion here, I'm not gonna run 700G in the video, but I'll post it here, the final power usage, and clocks I'm not probably gonna use it, just more concerned if somebody interested in the power usage here at the final stage. So at the end of the video, I'll have a screenshot of this, and I'm just want to talk about how I got there for each clocks. All this is separate. I have fan power usage on the fan, and separately just power usage on your ASIC, on your miner here on 12 volts, here on the power usage on your right here on your 20 volts system. So because you're going to be using barrel connector here, so it's looks like pretty safe to use barrel connector here, because you're probably not going to exceed 10 amp, I hope, 247 watts, but at the wall. So here you're probably about 230 at 20 volts, so you're, well, you possibly there are getting close to 10 amp there, because of the efficiency of your also of your PSU, right? Now when you're going on the 12 volt here, so definitely do not even try to use power connector, because I mean barrel connector. Need to slide this up so you could see. Now the last column here represent the heat sink temperature with the camera. So what I did is the thermal camera, I would go and record the temperature there, and you can compare to the temperatures that I have on my monitor tool, because there is a temperature there, and you can just have the idea how it's there for these all three miners. There go 1 2 3 here, and I get 1 2 3 in you can pause the video and just compare on your sensors. Temperature is, it looks like on mine is pretty close, like 60 58 on the highest and 58 on the in highest. So but if you look at my temperatures readings on the thermal camera, you have 66 85 and 74 on this final clocks on the 700 GL. I'm not even gonna try 700G, because that's gonna even probably overheat even more your MOSFETs, and you need more airflow and more concentrated air that I already trying to achieve. But if we able to use GL, like say 700 GL, all three of these miners set up right now on 700 GL, and if we able to run over around 700 gigahash, I think we achieve what we need to. If for some reason we can't take it on GL, you may want to try G version, but you add probably another 10 watts of power. I'll try to post, I'll probably just get one of them and add what's the wattage extra there. Maybe I'll do this on 12 volt and add, it's probably going to be 10 extra watt, I guess, for the G version using on that 700G. And what else I was going to talk about? So yes, the temperatures of the chip is very, very low, 5965, 5968. So it almost, to me, like they need to be a little bit warmer, closer to like 60, between 60 and 70, more like this, to get a higher hash rate, hopefully. But we'll see which one of this miner. I'll keep them for a couple days, and hopefully update in a few days which one of them perform better. Obviously, my hottest one right now is this that I have temperatures 85 over here. For some reason is just running hotter. Now, maybe I need to remove these fans, but the coolest one, the one that I removed those internal fans, is the last one. So you could see the temperatures there a lot better, always cooler at the end, and they were hottest actually before I removed and concentrate the air. You could see it was running 110, 112 degree on my camera here at the very end here. Maybe hard to see. I'm gonna shrink it down a little bit so you could see this last column right there. Okay, so the 110, 112 before I removed the internal fans and tape it around the miner to have more concentrated airflow, and got my power. See, like it was only 3 watts. I was using on a low speed here, and then I added to 3,500 RPM or something like that, and then now it's running at 45 to 5,000 RPM at this final. Let's see what we have. See, like the 246 power consumption, 90 degree is the ambient temperature here on this 20 amp miner. So this is on the 20 volt PSU. 246 at the wall, power consumption, 90 ambient temperature, and fan is on a separate power supply right there on the server PSU. So that's another 15 watt on top of it, and it's calculated into the efficiency in right here in this column. I have added the fans to this, 2 of this power consumption, and that's a gigahash per watt on this efficiency column. All right, so you're welcome to pause and check this spreadsheet there. So let's check also the 12 volt. If anybody doing on the solar, you have 215 almost watt, 214 to 215 watt, and I'm adding here from 95 96, so about another 17 18 watts for the my fan, because it's running at 5400 RPM right now on this, on Fruition Design. And interestingly, I haven't taped the sides of the miner to have better airflow, and it's still running pretty good. So I guess I have better luck with this silicone on these MOSFETs. And the last one is running 5400 RPM, is the one in the box, mining box. So that's pretty much it. Just gonna update this, and at the end I'll just have a screenshot of this maybe for a minute or so, so you can pause there at the end and look at that spreadsheet. So let me update this to 700G, and then I'll put it back to GL. If it takes GL, that's probably your best bet, because it uses the less power, most efficient, and you may potentially get this, stabilize this, and hopefully get closer to 700, or like this one, 713 gigahash. It would be nice to see on the pool data after maybe a few days, so we can have full 24 hours, and I'll may update you guys on that in a few days. All right, so let me update to 700G, and I'll post this final spreadsheet there, and this I'll do the screenshot of this. By the way, I have screenshots of every clock starting with 562, so I can slowly go through here. Let's see, I'm just gonna probably, what I can do is, so you can guys see the temperatures here. All right, so you can pause anytime this video and look at this 3 miners, just so you can compare the temperatures on the chips. And this is 562 G version. Okay, and then we go 562 GL. Gonna scroll down. Okay, and then I have 562G high, so that's on the high version. And you see this was overheating, so I basically had to, first mine was restarting, so I had to turn it down. It didn't take that clocks on the high. 618 G, no, I take it back, 562 was fine. For some reason it didn't take shot, it was restarting or something like that. So now, oh, I bricked that unit actually during this video. So I bricked one of the unit, and I had to switch to that different IP address, if you notice, because I bricked by uploading wrong firmware. So that's another thing. You have to be really careful when you have multiple units and you updating those. So let's look, that's 618G, and we have 618GL data for you right here. All right, so you can pause and check all the information, and then you have 618GH. Okay, so that's the high. On the high version, I didn't keep for too long, see, only like 20 minutes, just to see temperatures and see how it will take the clocks. But this was already heating up so badly on the, and this is just because of the fan was not powerful enough, I believe. Now let's go to 676G. 676G. Okay, let's make it so you could see the time frame. Also, it's over an hour, so mainly I try to keep them a little longer than an hour. And then I have 676, so basically goes to 700 GL, which is running right now, right over here. So I'm gonna take a screenshot, just add there. You can pause the video and see over after an hour the update. And I'll go to 700, so 700 GL right now, and 700G will be the final. So just look at the end of the video, the final spreadsheet. All right, guys, I was not gonna record this last 700G version, but what happened is 2 of my miners actually failed on overheating. The way I know it, because when it goes start mining and it drops, that's exactly when you're I'm gonna restart this one just to maybe show you again, but that's what happens to your heatsinks. It just overheats here and the temperature quickly drops to wherever ambient temperature. See, like this one keep on climbing, this one also failed. I restarted and I apply more air, but it looks like it's keep on climbing the temperature and it will fail eventually. This one, that's very hot, but it's been mining for 17 minutes, but it's not performing very well because of the, I could see this not even taken to 700. So 700G will be something more advanced because it uses also a lot of power. If you look at this, oh, it's already dropped. So it was 282 watts on 20 volts system. Now I cannot see it on 12 volt because of the this watt meter only kind of records 230 watts maximum. So I assume it's like over 230 on the 12 volts, so maybe 235 or something like that. So I can determine that by I'm gonna restart this miner that's on the solar, and I'll check the temperature. I'll check the, so potentially we'll take that maybe a hash rate, but I'm concerned about temperature rising here, and it's probably not a good idea to keep there if it's using so much power. So I'll show you how am I gonna determine the wattage on 12 volt, because it's consuming 615 total watts right now on solar. Once I restart, I will see where this power gonna drop down. Okay, so let me actually put back to GL and restart at the same time, so this way I'm not wasting time there. So I'll put back 600 GL, the one that was working actually okay before, and I'll click update because we don't want to overheat that. And after we'll ask to restart the miner, we'll see this drop, and we'll calculate the difference between 613, 615 watt, and what is it gonna be when it drops to 0 on our power usage just right here. Okay, so let's get that restarted. Okay, and let's see the power consumption after it drops to 0. Okay, we'll drop this wattage to 0 here. All right, now 0, and it's 360, looks like what, 358. Okay, so 358, and we see in 615 357, 355. So let's say 350, Wow, even 352. So okay, let's 355. Let's use 355, and we'll deduct 615 minus 355. Will be a use easy calculation. So it's 260 watts, guys. Even on 12 volts, it's ridiculously high. So don't even think about barrel connector at any of these overclocks. So potentially it would take probably 700. Highest I've seen 680, but it's very dangerous clocks, 700G. It only if you have really prepared all that settings there. I couldn't even measure the temperatures. I think both of these kind of overheating above 100, so there is no way without modification I can mine with this. So, and this one I haven't measured, but I assume it was close to 80s according to the temperature of the, or 75. So unfortunately I didn't measure exactly that temp, but I don't think anyone will try to work on that temperatures. And I'll put 680 for all of my, well actually it's probably went to around 700s on this clock. So let's see. Yeah, I couldn't even start on 2 of these, so it would be pretty much failed. And I went about 280, I believe 200, almost 300 watts here. So this is crazy, this is insane. 300 watts here. So yeah, I don't know guys, if you are gonna be lucky enough to start this and hopefully mine with this setup. But let's see, 260 watts on 12 volt compared to now when I started it's only 214 on GL, so it's a huge difference, almost 47 watts difference. So that's a lot of power to use for G. So if you like it on GL, I definitely recommend stay on GL. Don't try to move from GL, because same on the 20 volts, it uses 282 watts. So I would say it's almost 80. Let's see if 330. What's our 80%? 330 watts times 0.8. So 264. I think it's the maximum that you want to load your 330 PSU. So if we went to 284, we already 20 watt extra. But if we're running GL, we're at the 247 watts there, right here. So that's pretty much below 80%. So that's pretty much safe way to run it. So I would recommend run even 330 watts. On the 330 watts, the G version may need to have a lot more modification done to cool it down, because as soon as it starts heating, it uses a lot more power for some reason. Okay, so keep that in mind. So let's I'll have to go back and reset. Let's see what's the usage here on this one. 572, right? 572, and we did calculation from 355. So let's just confirm that 572 minus 355, so 217 watts. So pretty close. What's our power reader goes to 14. So about 3 watts difference there, because it consumes the power reader, probably also using a little bit of the extra wattage there when it's in use, about one watt maybe, and then the extra power actually on the drops of the wattage goes when it cools down, and it drops wattage on our fan as well. Okay, so that's it guys for this video, and this is the final spreadsheet, I guess, if you guys want to see it. Unfortunately 700G, I don't have a lot of data here. I don't know if I want to even put here, this one is failed, so I don't know if that's gonna be like 600 just for efficiency, very bad efficiency. And you can see the efficiency here is actually compared to the KS5L and KS5M, which are 441 for 353. So right around here you are still doing almost like KS5L unit, and if you want to be more like KS5M or higher efficiency on the stock clocks, you get that on 20 volt power consumption as well. So that's, I think that's pretty good for the stock firmware as far as the efficiency goes. And obviously if you want to get more of the hash rate, that's where you need to be more closer to this GL. Hopefully use GL all the time if your chips are happy with that. And a silicon ladder, again, don't take my word for it, but I think it's a pretty good data to use for you to decide where you want to be and how much fan power you're going to use, how much more power you need to run all of these clocks all together. Right guys, so this video is super long, but I hope it will help someone to make a decision. So stay tuned for the updates. I will be using only GL version. Hopefully I can run it for a longer time. It's not gonna overheat for me. So stay tuned for that, and we'll see you on the next one. Thanks for watching.